So in the last video, we discussed about how do we find area left of 1.2 or right of 0.5 like that. So what we did is find the probability that G is less than 1.2, right? So we did this type of problem. How do you find this probability? Is you draw the figure. I suggest to draw the figure for every problem of this type. So 0 is in the middle. Why? Because this is the standard normal distribution, right? The mean is 0 because when we denote by G, when you write with using G, that is the standard normal. And it says less than 1.2. So 1 will be somewhere here. 1.2 may be somewhere here. And you want to find all the area left of that. Less than that means all the area left of that, right? What is the calculator syntax? What is the left bound? Left bound is negative 10 to the 10. So we use normal CDF, norm CDF, and then negative 10 to the 10, and then 1.2 is the right bound, that is 1.2, right? And then mean is 0, sigma is 1 because this is the standard normal. The second one is P, probability that G is greater than 0.5. It is same as, just draw the graph, okay? So there is 0, so 0.5 maybe somewhere here, right? That is 0.5, and you are trying to find out this area, okay? So what is the left bound, right bound? For normal CDF, norm CDF, right? Left bound is 0.5, this is 0.5, and then right bound is 10 to the 10 you can write because it keeps going, that's why, and then mean is 0, sigma is 1. So these are the calculator syntax, norm CDF, to find out the area left or right. And on the last one you have like this. So 0 is there, negative 1.5 maybe somewhere here, negative 1.5, 1 maybe somewhere here. So you are trying to find out the area between these two G values, right? This shaded area. So how do I find out that? Is norm CDF, and then left bound is negative 1.5, right bound is 0.5, right? 0.5, and then mean is 0, sigma is 1. This is what we did, and we used calculator. How did we use calculator? So if you are using TI-84 calculator, then let me do TI-84 calculator, okay? So TI-84, so how do you find out the area? Is to find out the area, you go to second and then verse and go to the normal CDF, that is number 2, right? For example, for the first one, the left bound is negative 10 to the 10, so it is 10 to the 99. It is even better. So what will be the right bound? Right bound is 1.2, right? 1.2. And then mean is 0, mu is 0, sigma is 1, and then you paste it. So you get the answer to the first question is 88.8849. That is the area left of that, 0.8849. And that makes sense because this the area left of 0 is 50%, 0.5, right? So area left of 0.12 will be bigger than that, and we got that one, okay? So for the second one, if you want to find out the area right of 0.5, what do? Is you want to, what is the left bound for this shaded region is 0.5, right bound will be infinity, or you can say 10 to the 10, right? So let's do that one. For the second one, you do normal CDF again, and left bound is 0.5, right bound is, you can write 10 to the 10 or 10 to the 99, whatever you want to. Mean is 0, sigma is 1, and then paste. This is what you get there, 0.3085 will be the answer to the second question. And for the third one, you are trying to find out the area between negative 1.5 and positive 0.5. So what do? That is second verse, go to the normal CDF again, okay, hit enter. So the left is negative 1.5, right bound for this shaded region is 0.5, right? And then mean is 0, sigma is 1, you paste it. So this is what you get, 0.6247, okay? So 62.47%, okay? This is one thing we learned in 6.1. And another thing is, if the area is given, how do you find the G values? How do you find out the normal score, right? Standard normal score. So let's make the figure for each of them and then show the work. So find the G value, so that area left of G is 0.1592. So what it says is, so there is a standard normal because we are talking about the G value. So G is 0 is in the middle. So it says you need to find the G value, so that area left of G is 15.92%, right? So where does the G fall? Does G fall on the right side or left side? Because since the area left of G is 15%, it must be somewhere here, right? G must be somewhere here, so that the area left of G is 15%. So how much is that area? Is 0.1592. You need to find out G. See, it is just the opposite of that. Here G was given, you are finding area. Here area is given, you are finding G. So to do that, you need to do inverse norm. So inverse norm, and area left of G is 0.1592 and then 0, 1. That's what you use. Okay. For the second one, it has area right of G is given, right? So this is the normal distribution, 0 is in the middle. So area right of G is 74%. So should G somewhere here or here? If G is somewhere here, then the area right of G, area of G will not be greater than 50%, because because it will be like 30% or so, because if G is 0, then the area right of G is 50%, right? So G must be somewhere here, so that the area right of G is about 75%. You see that? So G must be somewhere here. Now, if you are using TI-84 or TI-83 calculator, it always requires you to enter the left area to find out G, meaning area left of G. So since that area is 0.7499, what will be the right area? That will be 1 minus 0.7499, right? So to find out that G, the G, what we do is you do inverse norm and then 1 minus 0.7499 and then mean is 0, sigma is 1. This is what you do, okay? Because the calculator requires the area left of G to find out G value. But if you are using TI-84 plus CE version of the calculator, you can just enter the area, this area, and then mention which side. Is this the right area or left area or the middle area? And then it will give you right away, okay? And the last one is middle area is 80%. So if the middle area is 80%, so the mean is 0 here. So if the middle area is 80%, then you will have to find out two G values, G1 and G2, right? G2. So what is the middle area? This is 80%, 0.8. So what area is left? What area is the right side, outside area? Outside area is 1 minus 0.8 is 0.2. So the total of the outside non-shaded part is 20%. So half of that is 0.1. That means this is 0.1 and that part is also 0.1. So to find out G1, what do you do? G1 is equals to inverse norm 0.1, right? And then 0, 1, because it needs the left area left of G1. For G2, what is the area left of G2? Inverse norm, right? Area left of G2 is this middle one is 80% and that one is 10%, that is 90%. Or you can see 1 minus right area will be 90% anyway, right? So 0.9 and then 0 and then 1. So you use that. Now to find out these values in the calculator, TI-84 or TI-83 calculator, what you do is for the first one you got inverse norm 0.1592. So go to the second and then verse and then go to inverse norm, because you are finding the G values. So the area is 0.1592, 0.1592, okay? And then mu is 0, sigma is 1, and you paste it, you hit enter, it will give you the value. So negative 0.9977. That's what the value of this. You write equals to and then write negative 0.9977, okay? Now let's do the second one. The second one has inverse norm 1 minus that, right? Because you need to enter the left area. That's why you subtract it from 1. So second and then verse and go to inverse norm, because you are finding the G values, and then do 1 minus 0.7499, 0.7499, okay? And then mu is 0, sigma is 1, and then paste, hit enter. After you select the paste, you get negative 0.67. That's the answer for that, negative 0.6741, okay? And the last one is, to find out G1, you need to enter the left area from G1. So what is the area left of G1? Then you do second verse and then inverse norm, right? So you do 0.1 and then 0 and then 1, okay? And then paste. You do that, This is what you get, negative 1.28. So if you do the last one, you will get positive 1.28 because it is symmetrical. Okay. Now another thing is, if you are using TI-83, then you need to select the inverse norm and then parenthesis start, and then you need to type all these things here. Okay. 0.1 and then comma is here. Okay. And then comma 0, comma 1, like that. If you do that, you will get the right area. So now, this is what we did in the last video. Now, instead of the G, instead of the standard normal, we will work about the normal distribution. That's what we will be working. Normal distribution only. Not G distribution, but we will be working about X distribution, meaning X will be a normally distributed with mean will be different from 0 and sigma will be different from the 1. Okay, but if it was G distribution, it was normal with mean was 0, sigma was 1, but now it is mean is different from 0 and sigma is different, or sigma is different from 1. So we will be working like that. Exactly everything will be same. Okay, all those calculator syntax will be same. Only the thing will be, instead of 0 and 1, you will be plugging in the mean and sigma values, which will be given by the question. Okay guys, all right, thank you. Okay, so let's start 6.2. So the standard normal distribution curve can be used to solve a wide variety of practical problems. The only requirement is that the variable be normally or approximately normally distributed. If X is a normally distributed variable, random variable, then we write X approximately, N is normal distribution, mean is mu, sigma is 1. Previously in 6.1, what did we learn? We said G is normally distributed with mean is 0 and sigma is 1. That's what the G is. But X can have non-zero mean or standard deviation different from 1. Okay. For all the problems presented in this chapter, you can assume that variable is normally or approximately normally distributed. Okay. If G is given, you can use calculator directly. If X is given, you can use calculator directly too. But there is another way. There are two ways to solve problems from this. One way is you work with X directly. Another way is you change the X into G by using this formula, X minus mu over sigma, and then use normal CDF or inverse norm, whatever you need to use. Okay, all right. So as in the previous problem, you can directly use like left bound, right bound, mu and sigma, or without changing into the G. So you can change into G or without changing into G. Okay, let us see these examples. For a normal distribution with mean is 20 and standard deviation is 2.3. Let us look at this. So mean is not 0. Sigma is not 1 here. What is given here is mean is 20. So mean is in the middle, right? Mean is 20 and standard deviation is 2.3. So we need to find out probability of X is less than 23. If this is 20 in the middle, 23 will be somewhere here, right? And you want to find out the probability that the X falls less than 23. This is what it is you are finding. So what is this? This is 23. That value is 23, right? Now how do I find out that? Using calculator. That will be, what is the left bound? Normal CDF. Left bound is goes to infinity, negative 10 to the 10, right? And then right bound is 23 here. Isn't this exactly similar to the previous one? Instead of writing 0 and 1, you write mean is 20 and sigma is 2.3. This is what you use. And then use calculator, okay, to find out exact value. So how do you do that? So since you are finding the area or the probability, okay, you need to use normal CDF. So you should be very careful on when to use normal CDF, when to use inverse norm. Normal CDF is used if probability is asked or area is asked. And inverse norm is used if area is given or probability is given and you are asked to find out the value. Okay. So let's do the normal CDF and then hit enter. So the left is negative 10 to the 10, which is negative 10 to the 99. It is given. So we are good with that. So what is the upper bound? Is 23. 23 is the upper bound. And mean is not 0. It is 20, right? Mean is 20. and the sigma is how much? 2.3, and then hit enter. So this is what you get. So left bound, right bound, mean, and sigma. If you enter that, you will get 0.9039. Okay, so this is what you get. So that is 0.9039. This is one way of doing that. So another way is, see, for above examples, first find the corresponding g value. Okay, so how do I find out the g value for the, if you want to do different method, is to find out the g value. Okay, so if you want to do the same problem by changing into the g, first of all, what you do is you need to find out the g value for 23. What is mu? Mu is 20. Okay, so mu is 20, sigma is 2.3. So the g will be x minus mu over sigma. That will be, x is that value you take as x, 23 minus 20 over, and then sigma is 2.3. Okay, so if you use calculator for that, what do you get? That will be 23 minus 20 and then divide by 2.3 is given as 1.3043. 1.3043. That's what you get for g. Okay, now how do you find out that then? So this is the equivalent. This g equals to 1.30 is equivalent to x equals to 23. Okay, so you can write, so probability that x is less than 23 is equals to, probability is the same as saying g is less than 1.3043. Okay, now you make that thing here. So instead of writing 20, because we are changing everything to g, so this is 0, 1.3 will be somewhere here, and you are finding the total area less than 1.30. So this is 1.3043. So how do you find out that? Is for this, the left limit is negative 10 to the 10, right limit is 1.30, right? So if you do that, then you will get, let us see that. Let me clear what I have. Second verse, and then normal CDF, right? Hit enter. So left bound is, that is okay for the left bound. Right bound is, instead of 23, you have right bound 1.3043. 1.3043. That's what you get. Okay, and mu is 20. Now mu is 0, right? Because we change everything to the g value. And then sigma is 1. Okay, and then you do the paste. So if you change the into the g value, then see 9039, 9039. That's what you get. Okay, so you can either change into g value and then do like this, or do directly using calculator. I mean, we will use calculator for the g value too, but if you do directly, you don't have to change that into the g value, right? So how about the second one? For the second one, the figure look like this. So what is the mean for this problem? Mean is 20, right? And it says greater than 19.5. Since this is 20 and it says greater than, means right side of 19.5. 19.5 may be somewhere here, and you are finding this area. Okay, what is the calculator syntax there? So the calculator syntax will be normal CDF, and the left bound is 19.5, right? 19.5, and the right bound is 10 to the 10, and then you do 20 and then 23. We used to use 0 and 1 if it was g, but we do not have g, we have x here. Okay, so if you use calculator for this, you will get basically, let me clear that, and second verse, okay, and then normal CDF, hit enter. So the left bound is, what is the left bound for the second problem? Is basically 19.5. That is 19.5, right? Because you want to find out the area right of 19.5. So you do 19.5 and then hit enter, and then the right area, the right bound will be, you can take 10 to the 10, very big number. 10 to the 10 is the right bound. Mean is, what was mean? Mean is 20, and the standard deviation is 2.3. 2.3, and then you go down and then hit enter. This is what you get, 0.5860. That's what you get, 0.5860, 0.60. That is 58.60% lies above that, above 19.5. Or you can say 58.60% of the population are bigger than 19.5, or the data are bigger than 19.5. For the last one, I mean, you can do this one exactly similar to what we did here. You find out G using x minus mu over sigma. So G will be x minus mu over sigma will be, so that will be 19.5 minus 20 over 2.3. So if you do that, you will get 19.5 minus 20 over 2.3. So that is basically I got negative 0.2174. Negative 0.2174. You want to find out right of that, right? You want to find out right of this. That means the middle one is 0 because we changed to G. So right of that value. So you're trying to find out that. So how do you do that? Is this probability of x greater than 19.5 is same as probability of G greater than negative 0.2174. Negative 0.2174. And then you use left bound for this will be negative 0.2174, right bound will be 10 to the 10 and then 0 and then 1. If you do that way, you will be able to find out exactly the same answer as here. Okay, so the last one here is basically, let me use green color for the last one. So here we have the mean is 20, that is given here, right? And then let's make a normal distribution, and you want to find the probability between 17 and 21. 17 will be somewhere here, 21 will be somewhere here, right? You want to find that area. So how do you do that? Normal CDF, norm CDF, left is 17, right is 21, mean is 20, sigma is 2.3. That is 2.3. Okay, if you use that, what do you get? So just apply that thing. So second verse, normal CDF, not inverse, no, normal CDF, left is 17, right is 21. That's what the question is asking, right? Mean is mu is 20, sigma is 2.3. We are good, so hit enter. This is very good. 5720, 0.5721, I would say. 0.5721. That is 0.5721. This is how we find out the area under the normal curve. If the standard normal, if G is not given, this is how we find it. Okay, let us do some more examples. An adult has an average of 5.2 liters of blood. What do you mean by average? Mu is given is 5.2. Assume the variable is normally distributed and has a standard deviation 0.3. Sigma is 0.3. So this is not a standard normal, right? Because mu is not 0, sigma is not 1. This is x, okay? Find the percentage of people who have less than 5.4 liters of blood in their system. What is asking is probability that x is less than 5.4 equals to what? So see, so 5.2 is the mean, right? And this is 5.4. You want to find out all the area left of 5.4, which is same as probability that the person selected has 5.4 liters of blood, or percentage of the people that have 5.4 liters of the blood or less. That's what we are trying to find out. What is the calculator syntax? You do normal CDF, norm CDF, right? Left bound is negative 10 to the 10. Right bound is 5.4 because you are finding area up to 5.4 from the left. And mean is 5.2 and sigma is 0.3. This is how you do it, right? So how do you get that? Is just use the calculator. So let me clear everything. So second verse and then normal CDF. Okay. So the left bound is let me clear that. So negative 10 to the, oh, by the way, that negative, it doesn't like that negative. We need this negative. Negative 10 to the 10. Okay. and the right bound is 5.4. 5.4, that is the right bound. Mean is 5.2, right? 5.2, and the sigma is 0.3. So you go to the paste and then do that. So 7475. So you get 0.7475. 0.7475. This is what is the area left of that. See, this is what we do. And 0.7475. Okay, now, so what is the percentage? That is 74.75%, right? If you want to write in terms of the percentage, you move the decimal to the two digits later, or two digits right. This is the straightforward way. Now, how about changing that into the G value? If you want to change that into the G value, what you do is, oh, by the way, there is a problem here. This is not 4.5. This should be 5.4. This is typo. 5.4. Okay. Now, how do you do that? Is, so to find out the by G value method, this is the direct method. Now we're going to do the G value method, meaning we need to find out G value first. So G is x minus mu over sigma. X is 5.4, mu is 5.2, over sigma is 0.3. If you do that, you will get 0.6667. Then x is less than 5.4. This is 5.4, okay? 5.4. Let me write down there. Not 4.5, 5.4 equals to, which is same as saying G is less or equals to 0.6667. Now you use normal CDF, negative 10 to the 10, because when you change into the G value, mean will be 0, right? 0.6667 will be somewhere here, and you are trying to find out the left area. Okay, now this is the left area. So how do you do that? Negative 10 to the 10, 0.6660, 6667, 0.6667, and then 0, 1, because we changed that already, that to the G. X is changed to G, that's why we need to put 0 in, and you will get the exactly the same value. If you don't believe on that, let's do that. So it is verse, and then do the normal CDF, hit enter. So the left bound is negative 10 to the 10, right bound is 0.6667, 6667, mean is 0, sigma is 1. If you hit enter, you must get 7475. That's what we got, right? 7475, which is 74.75%. Okay, so this is how you do it. So you can do both way, but sometimes the book, the online homework asks G value method. Sometimes you can do it directly. Okay, so you can do either way in the test, but in the homework sometimes it asks G value method, sometimes it asks direct method. Okay, let us do this example number 3. Each month, an American household generates an average of 28 pounds. So what is mu? Mu is the average, right? 28 pounds of newspaper for garbage or recycling. Assume the variable is approximately normally distributed and the standard deviation is 2. Sigma is equals to 2. If a household is selected at random, find the probability of generating between 27 and 31. So what do you do? Probability that 27 less than x less than 31 equals to what? If you do it directly, how do you do that? You do, let me make the figure for that. So the mean is 28, right? 27 is somewhere here, 31 is somewhere here. So you are trying to find out the area between those two. So 27, 38, right? So how do you do that? Is normal CDF. The left bound is 27, right bound is 31, mean is 28, sigma is 2. If you enter that, you will get the answer. Okay, now it says use both direct and G value method. To do the G value method, what you do is you find out the G value for this, okay, and you find out the G value for the other one. Find the G value for this one, find the G value for the other one. So let's find, let's say G1 is x minus mu over sigma. That is 27 minus 28 over 2, right? That is negative 1/2. That is negative 0.5. That is the G value for that x value, okay? Similarly, G2 will be x minus mu over sigma will be 31 minus 28 over 2. That will be 3/2. That is 1.5. So now probability that 27 less than x less than 31 is same as probability that negative 0.5 is less than g less than 1.5. So we change the x problem into g problem. Okay, now how do you do that? Is you just make a normal distribution. Since it is the g, 0 is in the mean, right? Because the g distribution has mean 0. And then negative 0.5 will be somewhere here, 1.5 will be somewhere here. So basically you are trying to find out that area here. Negative 0.5 and then 1.5. So what is the syntax? Normal CDF, right? Mean is, and the left bound is negative 0.5, right bound is 1.5, mean is 0, sigma is 1, because we change that into g value. Okay, now let us use calculator for both. You must get exactly the same value from both method. Okay, so let us look at that. Okay, so let me clear everything I have. Second verse, so normal CDF. All right, what is the left bound here? Negative 0.5, negative 0.5, right bound is 1.5, and mean is 0, sigma is 1. I'm doing basically the g value method first. Okay, if you hit enter, you will get 0.6247. Now if you want to do the direct method, then direct method is also similar method, right? Normal CDF, left bound is 27, and the right bound is 31, right? What is mean? Mean is 28. Instead of 0 and 1, you need to replace by mean, and the standard deviation is 2, right? And if you hit enter, so you will get 0.6247 again, exactly the same value. So either method will give you exactly the same value, 0.6247, 0.6247, 0.6247. That's what you get. Okay, so either way you get the same value. So you can use this method or that method. Now, how about more than 30.2 pounds per month? If you have more than 30.2, it is asking probability that x is greater than 30.2, meaning if you do the direct method, so the mean is 28, so greater than 30.2 is basically asking that, right? Because 30.2 is somewhere bigger than 28. So what will be the normal CDF? Norm CDF, left bound will be 30.8, that value, right? 30.8. Right bound is, it keeps going on the right side, so 10 to the 10. Mean is 28, sigma is 2. You can do that way. And if you want to find out with the g value method, then find out g first. So g equals to x minus mu over sigma. That will be 30.2 minus 28 over 2, right? What do you get? That is 30.2 minus 20 is 2.2 over 2. That is 1.1. Okay, now if you make the figure for this, you will get the figure will look like this. So there is, because this is for the g distribution, so mean is 0, right? So 1.1 is somewhere here, and you are trying to find out the area right of 1.1, right? So how do you do that? Is normal CDF, 1.1 is the left bound for this shaded region, and then 10 to the 10 is the right bound, and then mean is 0, sigma is 1. So either way, you must get the same answer. Okay, let us check using the calculator. So you get second verse, go to the normal CDF, hit enter, you get the left bound is 1. So let's do the red one first, the direct method first, because mean and standard deviation is already there. So 30.8, 10 to the 10. So 30.8, and then go down, is the right bound is 10 to the 10. Okay, and mean is 30, it is already given, sigma is 2 is given, so the paste. This is what you get, 0.0807. And if you do the other way, you will get exactly the same answer, 0.0807. So 0.0807. So either way, you will get the same answer. Okay, so if you are using TI-84CE plus, you don't have to it's exactly the same way. So you don't, it's different in the inverse norm, but for the normal CDF, it is exactly the same way if you're using TI-84CE plus. Okay, So a desktop PC used 120, that's another example, watts of electricity per hour based on 4 hours of use per day. The variable is approximately normally distributed and the standard deviation is 6. Okay, what does that mean? What is the mean? So that is the mean. Okay, so mu is equals to 120. Sigma is given as 6. Sigma is given as 6. So if 500 PC are selected, approximately how many will use less than 106 watts of power? So let us find out for one PC first. If one PC is selected, what is the probability that X is less than 106? Okay, see, first find the G value, then find the probability. Finally multiply by 500 to get the number. So this is the G value method. It is asking for this hint is for G value method. But if you are doing direct method, then how do you do that? Is, so here mean is 120, right? It says less than 106. 106 may be somewhere here. So less than that. So the question is asking less than this. Okay, so how do you do that? Is 106 may be somewhere here, and you are trying to find out the probability less than 106. So what is the normal CDF? Norm CDF, left bound is negative 10 to the 10. Right bound is 106. Mean is 120. Sigma is 6. If you do that, you will get what is the probability. Is basically second verse and then normal CDF, hit enter. Left bound is negative 10 to the 10, 10 to the 10, right? And then right bound is 106 for that shaded region, and the mean is 120 and sigma is 6. If you do that, if you paste this, 0.0098, so 0.0098. What does that mean? That means if you select one computer, what is the probability that that computer uses 106 watts of power? Is 0.0098. But how many PCs are selected? 500, right? So the number of computer that uses less than 106 units of power is 500 times 0.0098. Okay, if you do that, what do you get? So you get 500 times 0.0098 will give you 4.9. So 4.9 computers, that is approximated by 5 computers. Out of 500, 5 computers are using less than 106 watts of power. So this is how you find out the probability if X values are given. So if you want to do by G value method, find out G first. Okay, so what do you do to find out G is basically, so you do G equals to X minus mu over sigma, right? So how to do that is X minus mu over sigma. X is 106 minus mu is 120 divided by 6. Okay, so you find out these values and then use probability of G less than that value, whatever you get there. Okay, and then use normal CDF, negative 10 to the 10, negative 10 to the 10, and what value you get for G there, and then 0, 1 if you want to use the G value method. All right.